Okay, so today what we're going to be talking about is area for similar figures and the perimeter of similar figures. We've talked about similar figures, and similar figures means that their sides are proportional to each other. Okay, and so if we have similar figures, their angles are congruent, but then their sides are proportional. Okay, maybe twice as big, etc. And so I think the big thing would be we can write proportions of their corresponding sides. And so 2 can go with 3, just like x plus 3 can go with 2x plus 2. Okay, because we've got similar figures, their corresponding sides will be proportional, and so we can write proportions and solve them to find the missing parts. So if you cross multiply, you're going to get 2 and then x plus 2, and that equals 3 and then x plus 3. And if you distribute, you get 2x plus 4 equals 3x plus 9. Solve that, you get x is equal to 5. Okay, so if x is 5, well, then that means that this would be 12 over here, and then this side right here would be 8. Okay, and so you can find missing sides if you have enough, if enough sides there. You can write proportions and solve them. And the thing is, if things are proportional, sometimes you can see that proportion and be like, oh, well, on the next set, notice you can see that to get from 8 to 24, they just times by 3. Okay, and so you can see kind of that scale factor. So you can kind of tell, hey, timesing by 3 will get you to this value. So the answer for you would be 18. Now, could you write a proportion and solve it? Absolutely. 8 goes with 24, just like 6 goes with x, if you call this x right here. If you cross multiply and solve it, you're going to get x is 18. What I want to reiterate is not only are there proportions you can write, but also there's a scale factor who will be the ticket to say, start with your original your shape. And if you know the scale factor, that's the factor, or factor means times, that you multiply each side by to get to your resultant figure. And so if you can see it easily, you can just use it to find your next parts. Okay, so in the next one, it's kind of hard to tell, like to get from 4 to 6, what would be that scaling factor? So it's probably easier to write a proportion, be like, okay, let's do 6 goes with 4. Okay, just like x goes with 6, if you cross multiply and solve, you're going to get 36 equals 4x. X is equal to 9. Okay, so this side is 9. Now, if you wonder what the scaling factor is, that's what we're going to talk about next, is sometimes you can see, like, what do you multiply by the original values to get to the resultant image? But sometimes, because we're looking for what you multiply to get there, you can do the inverse or division. You divide the result, the image over the pre-image, to get that scaling factor. So in this question here, you would do 6 over 4. You could do like this value over this one right here. 6 over 4 would be 3/2. So the scaling factor between these two shapes would be 3/2. That means if you take 6 times 3/2, you get 9, and you do. Okay, if you take 3 times 3/2, you would get this bottom part as well. Okay, so proportions are true. There's also a scale factor to get from one shape to the other, something you multiply by every side to get to the resultant answer. So that's called the scaling factor. Notice you can see it here. 8 times 3 makes 24, but you'd also get it if you did 24 over 8, you'd get 3. Okay, so there's a lot of things that happen with similar figures, and I know we've studied that already, but I think with your older, stronger brain, let's talk about these concepts now to make sure that we get the most out of this course. Okay, so I want you guys to practice in the box looking at what is the scale factor? What do you multiply the values in the pre-image by to get to this here? Now, if you can't tell, then just do the image over the pre-image, the result over the pre-image. So you do 3 over 12. Oopsie, I got to get that. So you do 3 over 12, which is 1/4. So that means take every side by 1/4 and you'll get to the resultant image. Could you cross the multiply and write proportion? Of course you could. But sometimes you want to know, what is that scaling factor? It's kind of funny that, sometimes doctors or moms will talk about, like, hey, if you go find your kid at 2 or 2.5 and you double their height, that's how tall they're going to be as an adult. And so, like, the scaling factor from a 2 or 2.5-year-old, I think it's 2 for girls and 2.5 for boys. If you times that by 2, that should be roughly what their height's going to be. Is that absolutely true? Who knows? Okay, but I would think that's kind of a good gauge, say, talking about scaling factor. Okay, so what's the scale factor here? Well, you could do 24 over 8, okay? But the answer is 3. How come? Because that's what you take every side in the pre-image by to get to the image, okay? And then the last one, what do you times by to get from the pre-image to the image? Well, if you divide 5K over K over 5, sorry, pardon me, you're going to get K. Notice 9 times K gives you 9K. So the scale factor will be what you times by the original values to get to the image. So proportions are super fine, and we're going to use them so much, but there's other things going on there that I want you to hold on to those as well. Okay, so what about perimeters? Okay, if you think about it, perimeter and side lengths are definitely directly related, aren't they? If you have a bigger perimeter, you're going to have a bigger side lengths, you're going to have a bigger perimeter. Okay, and so the thing is, in similar shapes, the ratio of corresponding sides is going to be equal to the ratio of corresponding perimeters. Okay, and so that is going to be written right here. Okay, if you write the ratio of the corresponding sides, you're going to get the same answer as the ratio of the corresponding perimeters. So we're going to demonstrate that on the top 2 questions and then use it. Okay, the demonstrations I'm not going to ask you to do by yourselves, but I just want to show you, and look, it's true. So if you write the corresponding sides of B over A, that's what I say, we're going to get a value. So K is going to equal, if you do 5K over 5. Hey, look at this. It makes K. Great. Okay. It gets a scale factor. Okay, what if we do the perimeters of B? If you add up all the sides of B, in 18, so it'd be 28K, and the perimeter of this guy would be 28. Look at this. If you write the ratio of the sides, and if you write the ratio of corresponding perimeters, you're going to get the same value. You're going to get the scale factor, or K. And so it's kind of a weird, you're going to get, they're proportional to each other. That's what we're trying to show here. They're proportional. So again, demonstrating, hey, look at this is a true fact. If you take a side of SUT over the side of this one, so pick any side and write the ratio of its proportional side. So let's do, I don't know, 15 over 10 and set that equal to the perimeter of this one. Okay, see if we can get that. We're going to have 36. Okay, you add up the 3 sides of the SUT, and then you put it over they show us what we're doing on the bottom here. The perimeter of this guy here is going to be 24. Okay, this reduces to 3/2, and guess what? This also reduces to 3/2. So the ratio of corresponding sides and the ratio of corresponding perimeters are going to be equal. We can write a proportion with those to find missing pieces. So I'm not going to ask you to demonstrate that. I'll ask you just to use it. Okay, so look at the next example. They say, hey, these 2 triangles are similar. Can you find the perimeter of the bigger figure? Okay, can you find the perimeter of ABC? Okay, well, how do you do that? Well, let's write the ratio of corresponding sides. So if you read the similarity statement, AB and DF are similar. So AB is here and DF is here. So the ratio, okay, is going to be, let's just kind of tell what we're doing. Let's do ABC and let's do DFE. Okay. So this is going to be sides. Okay, so the ratio of the sides of ABC is going to be 12. The corresponding side would be 8. Okay, make sure you got the corresponding side, and this is going to be the perimeter. Okay, the perimeter of, we can find the perimeter of DFE by adding those together. You get 20.8 if you add up these 3 sides in DFE. Okay, but we don't know the perimeter of ABC. So because sides directly impact the perimeter of a shape, well, you can write the ratio of corresponding sides and set equal to the ratio of the corresponding perimeters. Okay, just make sure you line up the shape. So ABC over FE, DFE is what I have. And so the perimeters will be the same. Cross multiply, and you're going to get 249.6, okay, equals 8x. Divide the sides by 8, and you're going to get 31.2. That means that the perimeter of that larger shape is going to be 31.2 inches. So it's pretty cute. And I mean, it definitely is logical that if the sides of proportional figures are going to be proportional, then the ratio of their perimeters also, which is directly related to the side length, will also be proportional as well. Now, what do you think we're going to do next? Well, areas, okay? Now, the thing is, areas are a little bit different because if 2 polygons are similar, then their areas are going to be impacted if you make a bigger shape, but they're not linear dimensions. Linear dimensions would be like, the perimeter or the length of sides. Area is squared factor, okay? It's 2nd degree. So they're not going to be proportional to the side lengths, okay? They're going to be related, but they're going to not be directly proportional to that. And so it says in the directions, in similar figures, because the sides are proportional, when you find the area of a scaled figure, the areas will be proportional to the ratio of the corresponding sides squared. Okay, the ratio of the corresponding sides squared. Okay, what do you mean? Well, notice if you take the ratio of the sides, you have to square them to set them equal to the ratio of the areas, okay? Because they're not proportional at this point, okay? The sides are proportional to the perimeter because those are both linear dimensions, but areas are not. Areas are square dimensions. So to set them equal, you have to square the ratio of the sides, and that will equal the ratio of the areas. And so what we can do is we can say, okay, let's show this. So the first two are demonstrations, okay, and then we'll use it a couple times. Okay, so demonstrations, okay. If you take the side length of two figures, okay, so let's do B over A, okay. So you do 5K over, say, 5, okay, and set the equal to the ratio of the area. So this is VB, and this is A, this is side lengths, this is area, okay, and so the area of the bigger shape, remember to find area of a shape, you multiply the two sides. So if you multiply 5K times 9K, you get 45K squared, because K times K is K squared. And then the area of the smaller one is just 45. Okay, now, how we've written it, you have the ratio of the sides equals the ratio of the areas. That's not true. You take the ratio of the sides, and to set them equal, you've got to square the side ratio. Okay, you got to square the top and the bottom. And so what you would get would be 25K squared over 25, if these cancel out, equals, and you cross these guys out, equals K squared. So it looks like it's true. If you just write the ratio of the sides and square it, that will equal the ratio of the areas, okay? And so if you do it numerically, okay, the same thing is true. Again, I'm not going to have you show it. I'm just going to have you use it. So this is kind of saying, look at, mathematically speaking, if you write the ratio of sides, so if we did like 15 over, say, 10, okay, so this would be SUT, and this would be PRQ. This is the sides, okay, and then the areas here, it's here. Okay, so to find the area, you do 1/2 times base times height. Okay, pardon me. So to find the area of the triangles, you do 1/2 times base times height. So to find the area of SUT, you do 12 times 9 and then divide it by 2, and you're going to get 54. And then to do the area of the other one, you do 6 times 8 is 48, divided by 2 is 24. If you divide 15 by 10 and you divide 54 by 24, guess what you get? You get the same number. You get 2.25. So it shows, we're demonstrating, hey, it is true. Okay, now let's use that principle. Okay, the ratio of the sides squared equals the ratio of the areas. Okay, so we're going to use that principle. Now the ratio of the sides is equal to the perimeter, just straight out, but the ratio of the sides squared equals the ratio of the perimeter, or the areas. And so here we go. So the first one, if you're trying to find the area of the second figure, okay, we got to do the ratio of the sides. And so we're going to do, and you got to decide, how do you want to do this? Do you want to do B over A or A over, it doesn't matter, just be consistent. So if you do the sides are 5 over 8, okay? So you got to square those if you're going to set them equal to the area. Okay, so the area, we don't know the area of this one, okay, but we do know the area of A is going to be 32, okay? So if you square the left, you get 25 over 64. That equals x over 32. So if you cross multiply to solve it, you're going to get 800 equals 64x. Divide both sides by 64, and you get x is 12.5. So that means that the area of the smaller figure is 12.5 centimeters squared. Okay, so they're related, but you just have to square the ratio of the sides to equal it to the ratio of the areas. So let's try the next one. Okay, if you do, again, B over A, it doesn't matter if you do A over B or B over A. Let's do the side lengths. Okay, just be consistent. So if you do 8 over 6, okay, and set that equal to the ratio of the sides, or the areas, okay, the area, x over 13.5, okay. Now that's not true. We have to square the sides. So you get 64 over 36 equals x over 13.5. Cross multiply, you get 864 is equal to 36x. Divide both sides by 36, you get x is 24. Okay, so that means that the area of the green figure is going to be 24 feet squared. Okay, so it's pretty cute. They're definitely related, and they're related by a proportion as long as you square the sides. Okay, the next one, okay, has you work a little bit backwards. Okay, I'll switch colors a little bit. Let's go with, okay, the ratio of the sides. Okay, so let's do B over A. Let's do sides. Okay, that's going to be 6 over x. Set that equal to the ratio of the areas. So it'd be 72 over 50. Okay, this is areas. But this is not true yet. You have to square the side. So you get 36 over x squared is equal to 72 over 50. Cross multiply, and you get 1800 equals 72x squared. Divide both sides by 72, and you get x squared is equal to 25. To get plain old x, you square root it. You get x is 5. And that would be 5 inches. Now, this perimeter is supposed to be on the next question, so sorry. I like that question. I think it's good. Again, the ratio of the sides squared equals the ratio of the areas. Now, because sides and perimeter are both linear dimensions, we could do the ratio of perimeters squared equals the ratio of the areas as well. And so if we call this guy x and we say, okay, let's call this is A and B. Okay, B. Let's do the ratio. Let's do B over A, and let's do perimeter. And that's x over 66. Okay, those are not related until we square them, equal to the ratio of the areas, 28 over 252. Okay, so as long as you have a linear dimension to set it proportionally to the area, you have to square that linear dimension, whether it's perimeter or area. And so you get x squared over 66 squared, I don't know what that is, equals 28 over 252. If you cross multiply to solve that, you're going to get x is equal to 22 millimeters. Okay, so that means the perimeter of the smaller shape is 22 millimeters. So proportions are going to be very helpful. You just have to know, how do you set them up? Linear dimensions are directly proportional. Linear to area would be square the linear dimension ratio and set it equal to the area. Okay, the last question is a little weird. Okay, it talks about you're making like a Barbie blanket. Okay, and so the ratio of the areas of these blankets is going to be 2.5. Okay, and so they tell you about there's a smaller blanket and a bigger blanket. The smaller blanket has an area of 50.2. So you're like, there's a lot of things that they want us to talk about. Well, one thing we know is that they're talking about areas. Okay, I can't spell area. Okay, and so the area, and then we have the big and small. So let's write the big and the small. We don't know the big's area, but we know the small's area is going to be 50.2. Now, normally they would tell us like, oh, the radius of the big and the radius of the small, and you have to square both those dimensions. Well, instead of actually saying the linear dimensions that we'd have to square, that they talk about the ratio of the circumference and you'd have to square it. They don't do that. They instead say the ratio of the areas. So we don't have to square anyway. They just say, hey, the ratio of the big to small blanket areas is 2.5. So we technically just say we know the left side and we don't have to square anything because we know that the ratio is 2.5 to 1. Okay, we know that they're related like that. And so the big over the small is 2.5 to 1. And so if you cross multiply to solve this, you're going to get the value for x, or the area of the big is going to equal 125.5. And that's going to be centimeters squared. Now they want the diameter of that big blanket. Okay, well, we did this in the last chapter. Since area equals pi r squared, so 125.5 equals pi radius squared. Well, to get the radius, we're going to divide by pi, and then we're going to take the square root. So dividing by pi, and then taking the square root, use the pi key, okay? And then take the square root. You're going to get radius squared is equal to 39.95. Take the square root, and you get the radius is equal to 6.32. And then we want the diameter, so it would be 12.64 centimeters. So I think the big thing is to be able to hear what you're given. We're given the ratio of the areas is 2.5 to 1. You're given the small area, and then cross multiply, find it. And so I think work with your homework to say, what can I do with ratios? See if you can set them up appropriately and solve. Thank you. Have a good day.